Okay, so it is January 27th, 2026. And I want you to take a second, just a real quick second, and cast your mind back to, I don't know, the ancient history of late 2023, maybe early 2024.
It feels like a different century.
It really does. Do you remember what the absolute peak of AI excitement was back then?
And I do. It was all about the magic trick,
Yeah.
right? You type a prompt into a text box and then just watch amazed as a chatbot, wrote a haiku about a dishwasher or something,
Or passed a bar exam.
right? Or passed a BART exam. We
Uh,
were fascinated that the machine could talk back to us in plain English.
And it feels like a lifetime ago because if you look at the stack of research we have on the desk today, and I mean, it is a massive stack,
Yeah.
it's very clear that the last year, maybe 18 months, has been about a fundamental shift.
Yeah.
A shift in the, I guess, the species of technology we are dealing with. We aren't just chatting anymore.
No, we aren't. We're handing over the keys.
Hmm.
And I think that is the real theme of this deep dive. We are moving from the era of chatbots to the era of agentic AI.
Mm.
These are systems that don't just generate text. They actually plan, they execute, and this is the key part. They fix their own mistakes out in the real world.
And to really understand what that means for your job, for your life, and frankly, for your sanity, we're going to connect some dots that, usually don't get connected. We have a brand new foresight report from the World Economic Forum on 2030.
Right. We also have technical transcripts from people at OpenAI and the researcher Francois Chalet.
We've got Oracle's Larry Ellison talking about building, like, city-sized power grids for this stuff.
And maybe the most surprising thing, we have a philosophical defense mechanism for humans that's actually derived from Carl Jung.
From Carl Jung.
Yeah, because if the machines are going to be always on and always doing, we need to figure out how to, preserve ourselves in all that noise.
It's a mix of the brain, the body, and the soul. So let's start with the brain, because the timeline for smart AI has just, it's accelerated in a way I don't think even the experts really predicted. We have to talk about Francois Chalet.
Right. For listeners who might not know, Chalet is a really heavy hitter in the AI space. He created Keras, which is this library that, tons of people use to build neural networks.
Well, there's a big deal.
He's a very big deal. And for the longest time, he was kind of the bear in the room, the skeptic. He was the one telling everyone, hey, calm down, memorizing the internet isn't true intelligence.
Exactly. He famously argued these models were just, mimicry engines. But we have a transcript here from a recent interview, and he completely flips his prediction.
Completely.
Back in mid-2024, he thought AGI, so artificial general intelligence, was a decade away. Now, sitting here in early 2026, he's saying 5 years.
He cut his timeline in half.
In half. So why? What happened?
Okay, so it seems to come down to a very specific technical breakthrough. It's called test time adaptation.
Test time adaptation.
And this appears to be the aha moment that changed his mind. You have to understand, before this new generation of models, the ones that started emerging late last year, models were essentially static.
Static how?
You trained them, you froze them, and then you just deployed them. That was it.
So they were kind of like a student who studied really, really hard for a test, memorized the entire textbook.
Yeah.
But once the test started, that's it. They couldn't learn anything new. They could only recite what they'd already memorized.
Precisely. If they saw a problem they hadn't seen in their training data, they'd fail. Or they would just hallucinate an answer based on what looked probable.
Okay.
But test time adaptation just changes the physics of the model. These new agents, they don't just blurt out an answer. When you give them a prompt, they actually search for the solution during the interaction.
So they're running simulations.
They're running simulations, they try a path, realize it's wrong, they back up, and then they try another path.
So are they actually thinking in real time?
In a functional sense, yes. They are spending compute power to reason through the problem before they give you an answer. It's a move from memorization to active problem solving.
Shullett used this analogy for this learning capability that I found, honestly, a little unsettling. He compared human learning to AI learning, and he brought up the Borg.
The Borg from Star Trek, yeah. It's a visceral image, but it's actually pretty accurate.
How so?
Well, think about how we learn. If I figure out some brilliant new way to organize a spreadsheet, or, I learn a hard lesson about managing a project, that knowledge it's trapped in my head.
Right.
Maybe I teach you. Maybe I write a blog post. But the transfer is slow. It's frictional. It's, biological.
But with AI.
With AI, if just one agent encounters a novel problem and solves it using that test time adaptation, that solution could be instantly propagated. So every copy of that model now has that building block.
So you have millions of agents learning in parallel, and they're all sharing this one global database of abstractions. It's not linear learning, it's exponential.
It's the hive mind.
The hive mind.
And that connects directly to the how. We have the transcript here from Jerry Tork, who's the VP of Research at OpenAI. And he kind of breaks down the mechanics of this. He talks about the shift from System 1 to System 2 thinking.
Which is that classic concept from Daniel Kahneman's psychology, right?
Mm-hmm.
System 1 is instinct, it's fast, it's
Yes.
automatic.
And System 2 is deliberate, logical, slow.
Okay.
So for a long time, large language models were purely System 1. They were just predicting the next word.
Yeah.
It was a reflex. But Turk explains that with chain of thought reasoning, they basically taught the model to verbalize its own thinking process.
It talks to itself.
It literally talks to itself step by step, and it's sort of hidden scratch pad before it gives you an answer.
I want to dig into how they actually trained that, though. Because Turk used an analogy that I think anyone who's ever had a pet will immediately get. He compared it to training a dog.
It's such a great way to demystify reinforcement learning. He explains that you need a pocket full of cookies, rewards. In the GPT-4 era, the cookie was given if the model just got the answer right. But for these new reasoning models, they completely changed the incentive structure. They started giving the cookie for thinking longer.
They rewarded the pause, the hesitation.
They rewarded the process.
Yeah.
If the model paused, break the problem down, checked its own work, and then answered, it got the reward. They incentivized the machine to be deliberate.
To show its work.
To show its work.
But that creates a friction for us, right, for the user. Tork mentioned this fast versus good dilemma. We've spent, 10 years being trained by Google to expect an answer in 0.2 seconds?
And that is the user experience shift we are all living through right now. We are entering a phase where speed is no longer the only metric that matters.
Yeah.
You have to decide. Do you want an instant answer that might be just okay?
Just average.
Or are you willing to wait 30 seconds, maybe even a couple minutes, for the agent to go away, think, do some research, and come back with a really reasoned, highly accurate solution?
It's almost like the difference between asking a coworker a question in the hallway versus, formally assigning them a project. You don't expect the project to be done in 5 seconds.
That is the perfect transition to the body. Because we are not just talking about a chatbot thinking inside a little window anymore. We are talking about agents that actually do work.
Right.
We have this report from Deloitte, Agentic Enterprise 2028, and they lay out something they call the autonomy ladder.
I have to admit, I usually roll my eyes at corporate ladders and frameworks.
Me too.
But this one actually helped me visualize where all this is going. Can you walk us through the steps?
So we started at the bottom. Assist and suggest. That's your spell check, right?
Yeah.
Your basic ChatGPT summarizing an email. But the leap we're seeing now in 2026 is to the top rungs. Execute and orchestrate.
Execute means what? I don't have to click the buttons myself anymore.
Exactly. You don't ask for a recipe, you ask the agent to go order the groceries. But orchestrate is the really big one. That's where the agent starts managing other agents. It manages an entire process.
Larry Ellison from Oracle had this amazing phrase for this in his transcript. He called it vibe coding.
Vibe coding, it sounds.
It honestly sounds like something a teenager on TikTok would say, not, a billionaire software tycoon. But what does he actually mean by that?
It's a funny term, but the concept behind it is profound. It means the end of syntax. You don't need to write Python or Java anymore. You declare your intent.
So you just say what you want.
You say, I want an inventory system that tracks widgets and alerts me when the stock is low. The agent gets the vibe, the intent, and it writes the code. It builds the database.
So the barrier to entry for building software just dissolves. But Ellison gave some examples that go way beyond just building apps. He was talking about healthcare on a scale that honestly blew my mind.
The Oracle examples were fascinating because they deal with the messiness of the real world, the bureaucracy. He talked about AI agents managing clinical trials.
But not just analyzing the drug data.
No. He meant handling the reimbursement rules between different countries.
That specific example about the Ozempic prescription really stuck with me.
It's a perfect case study of orchestrating. The agent looks at a patient in the UK. It figures out, okay, the NHS won't pay for Ozempic for this condition, but they will pay for this alternative. Then it talks to the U.S. payer systems. It handles the bank transfers, updates the patient records.
Wow.
It automates all that administrative friction that usually takes humans weeks to sort out.
That's amazing, but it is also terrifying because Deloitte points out a massive risk here. If you have decisions, Who is watching them?
Guardian agents.
It sounds like something from a sci-fi movie.
It does, but it's a necessary architectural layer. As AI does more and more, we need specific AI agents whose sole job is to supervise the other agents. They're the compliance officers. They check for safety, for bias, for hallucination.
It's a whole hierarchy of digital workers.
It is. And these digital workers need a place to live. And we can't ignore the physical reality of this. Ellison dropped a number that I actually had to double check. He said they were building data centers that use 1.2 gigawatts of power.
1.2 gigawatts.
Yeah.
For context, that's what, a nuclear power plant?
It's enough to power a city of 1 million homes. Or, if you want a pop culture reference, it's almost exactly what Doc Brown needed to power the DeLorean in Back to the Future.
But this isn't for time travel. This is for one training cluster.
One.
That really redefines the word cloud, doesn't it? We think of the cloud as this ethereal thing.
But it's actually acres of copper and silicon and massive cooling towers. Ellison calls them electronic brains. And he's right. We are building a new species of infrastructure that rivals the scale of our biggest cities.
Which brings us to the fork in the road. We've got these massive 1.2 gigawatt brains. We've got agents that can reason and execute. So where does this take the economy by 2030? The World Economic Forum report lays out 4 scenarios, and they aren't all pretty.
They're stark. The WEF basically says the future hinges on 2 variables. How fast does the AI tech advance? And how quickly does the workforce adapt?
Okay, let's look at the extremes. Scenario 1 is supercharged progress.
That's the techno-optimist dream, right? You have exponential AI improvement, but you also have a workforce that's nimble and ready. Productivity soars. Humans stop doing the grunt work, and we all become agent orchestrators.
We become managers of digital fleets.
Exactly.
Sounds nice. But then there's scenario 2, the age of displacement.
This is the one that keeps economists up at night. You have that same exponential AI, but the workforce isn't ready. The report describes a culture of accelerationism. Businesses realize, hey, this agent is cheaper and faster than my staff, and they just race to automate to survive.
And because the workers aren't trained to be the orchestrators?
They just get replaced. The report predicts a huge spike in unemployment, social fracture. And interestingly, it mentions the rise of state-like companies.
Explain that phrase.
Well, just think about those 1.2 gigawatt data centers. How many companies can actually afford to build a nuclear-scale facility? 3, maybe 4.
Right.
If those few players control the models that run the whole economy, healthcare, banking, coding, they effectively become more powerful than most nation-states.
That sounds exactly like the risk that Percy Liang from Together AI was warning about in his interview.
Percy Liang is such a critical voice here because he's looking at the power dynamics. He's arguing against that centralization. He talks about the risk of capture.
So if we end up in that WEF scenario 2,
It's likely because a few closed organizations are holding all the cards.
and his solution is what he calls a Linux for foundation models.
Decentralization. Open source. He's arguing that we need transparent models where we can inspect the weights, understand the bias, and crucially run them on our own hardware. It prevents the knowledge of the world from being locked behind some proprietary API.
It's the only way to ensure that agentic AI serves us, rather than us just serving these state-like companies.
Exactly. It preserves human agency in the loop.
But speaking of agency, there is another layer to this, a psychological one. We've talked about the brain and the body of the AI, but what happens to our souls? If we have these agents that act instantly, 204/7, never sleep, how do we compete with that?
You don't. And this is where we really need to pivot to that transcript on Carl Jung. It feels like a left turn, I know, but it is actually the missing piece of this whole puzzle.
The concept he had of excessive availability.
Right. The argument, and it's derived from Jung's psychology, is that being always available is a kind of self-abandonment.
Huh.
In an age of AI agents that never sleep, we are conditioned to just react. Notification comes in, react.
Yeah.
Email comes in, react. Agent finishes a task, react.
We become inputs for the machine. Jung had a word for this, didn't he? He called it being a puppet.
He did. Jung views the mind as an energy system. He talks about psychic energy. And if you spend all your energy just reacting to the external world or your AI tools, you have nothing left for individuation.
Individuation being the process of becoming a real sovereign person.
Correct. You can't become a sovereign self if you are just a node in the network, constantly pinging back.
The source material also made a connection here to Yuval Noah Harari regarding stories.
Yes, Harari often points out that corporations, money, nations, these are all just stories we invented. The Jung transcript connects this by saying, If you are just reactive all the time, you are living in someone else's story. You are living in the algorithm's story.
Oh, that hits hard. Because if the AI is the ultimate doer, the ultimate available agent, then our power isn't in trying to outdo the AI. We can't outgrind a 1.2 gigawatt data center.
No, our power is in withdrawal. The ability to disconnect, to choose to be unavailable, to observe rather than just react.
So as these systems get faster,
As they get faster and more autonomous, the uniquely human trait becomes the ability to just stop, to step out of the loop and decide why we're doing any of this in the first place.
it's the human defense. While the AI is focused on test time adaptation and solving the problem instantly, we need to focus on silence.
Precisely. Think back to those guardian agents that Deloitte talked about. Who supervises the guardian agents? That has to be a human. But it can't be a frantic, reactive human. It has to be a human who isn't caught up in the algorithmic speed, someone who has preserved their own sovereignty.
So let's just recap this whole journey because we've covered a lot of ground. We started with the brain chullet and Twerk telling us that AI isn't just memorizing anymore, it's learning from the collective Borg and reasoning through chain of thought.
Then we saw the body, Ellison, and Deloitte mapping out this massive new infrastructure. Agents that can orchestrate healthcare and write code, all powered by energy grids that could light up a whole metropolis.
We looked at the economic crossroads, the WEF warning us that if we aren't ready, we could face displacement by these state-like companies,
Yeah.
and Percy Liang arguing that open source is our shield against that capture.
And finally, we found the soul with Jung, the realization that as machines become infinitely available, our greatest asset becomes our ability to be selectively unavailable.
It really changes how I look at my phone and honestly, how I look at these new AI tools. It's exciting, but it's heavy.
It is. We are building tools that are designed to be perfectly responsive. We just have to make sure we don't accidentally train ourselves to be the same way.
So here is a final thought for you to chew on as you go about your day. We usually measure intelligence by speed, right? How fast can you solve the problem? How fast can you reply to the email? But by 2030, in that agentic enterprise world, speed is going to be cheap. The AI will always be faster.
So maybe the ultimate luxury and the ultimate sign of true human intelligence in the next decade won't be how well you use AI. It will be how capable you are of being unavailable to it. Can you afford the silence?
That's it for this deep dive. Thanks for listening, and we'll see you next time.